Hello and welcome to my science tutorials. In today's video, we are going to be talking about Raoult's law and lowering of vapor pressure calculations, that is, colligative properties. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So we want to first of all start by looking at what colligative properties are. So colligative properties are those properties of dilute solution that depends only on the number of solutes in a solution and not on its size or chemical nature. Simply put, colligative properties depend on the mole of the solute present in solution. Now these properties include 1. Lowering of vapor pressure, 2. Freezing point depression, 3. Boiling point elevation, and 4. Osmotic pressure. Now it is important for us to know that these properties are all related to each other. So once you are able to find the vapor pressure depression, you can easily find the freezing point depression, the boiling point elevation, and the osmotic pressure because they are interrelated. Now in this tutorial we want to look at the lowering of vapor pressure. That is the first one that we have over here. So we are going to look at what? The lowering of vapor pressure. The lowering of vapor pressure. Now, the vapor pressure of a pure solvent is lowered when a non-volatile solute is added. Now, this is because what? The vapor pressure of a solvent is caused by the evaporation of the solvent molecules on the surface of the solvent. Okay, so we have a solvent and then some of the solvent particles will evaporate, okay, because there is maybe sunlight coming down on them, and so some particles on the surface of the solvent will evaporate. Then once they turn into vapor, this vapor exerts some pressure on the solution or the solvent, and that is what we are calling the vapor pressure. Now when we dissolve a solute, okay, the surface area reduces. Okay, the surface area where the molecules of the pure solvent will evaporate, it reduces because we now dissolve a solute in the solvent. So the surface area is reduced, and therefore the amount of solvent molecules that becomes vapor and exert pressure now becomes less compared to the pure solvent, and this is what causes the vapor pressure of the solvent or the solution to reduce. Now if we are representing P, okay, as the vapor pressure of the pure solvent, and we are using PS as what? The vapor pressure of what? Solution. Then we can say the vapor pressure depression or lowering of vapor pressure, which is delta P, will be equal to what? The vapor pressure of the solution will be less than the vapor pressure of the solvent because we are having the vapor pressure being lowered. So we have what? P minus what? PS as the vapor pressure lowering or the vapor pressure depression. Now we can also calculate the relative lowering of vapor pressure, the relative lowering of what? Vapor pressure. And if we want to find the relative, we just divide the vapor pressure lowering by the vapor pressure of the pure solvent. So it becomes what? P minus PS over P as the relative lowering of vapor pressure. Now there is a rule that we call Raoult's law, and this law states that the relative lowering of vapor pressure of a dilute solution is proportional to the mole fraction of the solute present in the dilute solution. Now we need to note something in Raoult's law. It states that what? The relative lowering of vapor pressure, relative lowering of vapor pressure, okay, is proportional to what? The mole fraction of solutes present in the solution. So which means, okay, We know our relative lowering of vapor pressure is what? P minus PS over P, to be proportional to what? The mole fraction of the solute. Okay, the mole fraction of the solute is what? The mole of the solute divided by the sum of the mole of the solute plus that of the solvent. Okay, now we know if we remove the proportionality sign, we introduce an equal to sign and then a constant. The constant in this case is just 1, so we have what? P minus PS over P to be equal to what? N minus what? N plus what? Capital N, where we are saying N is what? The mole of the solute, and capital N is the mole of the solvent. Alright, so now that we know this formula, let's look at how to use it to calculate for an example. Alright, so the first example we want to look at is we are to calculate the vapor pressure lowering caused by the addition of 100 gram of sucrose with a molar mass of what? 342 gram per mole to 1000 gram of water if the vapor pressure of the pure water at 25 degrees Celsius is 23.8 millimercury. So let's write down our solution. So we are to calculate the vapor pressure lowering, that is what? Delta P is what we don't know, by the addition of what? 100 gram of sucrose. So our solute, okay, has the mass 100 gram. Okay, now the molar mass of the solute is what? 342 gram per mole. Now we added it to what? The solvent, that is the mass, is what? 1000 gram, and then the molar mass of water, which is H2O, we know is 2 into bracket hydrogen is 1 and then oxygen is 16. This is what? 18 gram per mole. Okay, now they are telling us the vapor pressure of the pure water, that is what? P is what? 23. Sorry, this is 23.8 millimercury. So from here we can simply go ahead and find what? Our delta P. We know that what? Our P minus PS over P is equal to N over what? Small n plus capital N. Now the P, which is the vapor pressure of the solvent minus the vapor pressure of the solution, can be set to what? Delta P divided by P, which is equal to what? N over what? Small n plus capital N. Now that means we need the mole of the solute and then the mole of the solvent. So let's find small n. Small n is equal to what? The mass of the solute, which is 100 on what? 342. So if we punch that into our calculator, we are going to get 0.292 mole. Alright, so let's find capital N, which is what? The mole of the solvent. So we have 1000 grams of the solvent in what? 18, which is the molar mass of the solvent. So if we do that, we are going to get 55.556 mole. So from here we can simply find our what? Delta P. We know delta P divided by P is what? 23.8 is equal to what? 0.292 on what? 0.292 plus 55.556. Now let me use this side. Now if we punch everything here into the calculator, we are going to get delta P here over what? 23.8 to be equal to everything over here is going to give us what? 0.00523. Now if we cross multiply, we get our delta P to be what? 23.8 multiplied by 0.00523, and this gives us the value of delta P, which is equal to what? 0.124 millimercury. So it means the vapor pressure depression caused by the addition of the sucrose, okay, 100 grams of sucrose to what? Pure water, that is 1000 grams of pure water, is 0.124 millimercury. All right, so now let's look at how to determine the molar mass from the lowering of vapor pressure. Now, the molar mass of a non-volatile solute can be determined by measuring the vapor pressure of the solution by dissolving a known weight of the solute in a known weight of the solvent. Now, we know that the change in vapor pressure, that is this, is equal to what? The mole fraction, that is this over n plus capital N. All right, so we are saying we need to how to calculate, okay, calculate the molar mass of the solvent, of the solute. If in case we don't know the solute that we are adding, we just know that we are adding a particular solute to maybe water or maybe an ether, and we want to find the molar mass through vapor pressure depression. How do we go around that? Now, let's look at this notation. For this particular example, the mole of the solute, we are going to use W as the mass of the solute, small w, and then we are going to use small m as what? The molar mass of the solute. Now, for the capital N, we are going to use capital W as the mass of the solvent, and then capital M as the molar mass of the solvent. Now, let this not confuse you by you saying the small m is mass. No, the small m is what? Molar mass, and we are using W to represent the mass in this case. Now, if we substitute these two equations, let me use this equation 1, equation 2. If we substitute these two equations into this one, we get that our relative lowering of vapor pressure becomes what? Small w over m, all on what? Small w over m plus what? Capital W over what? Capital M. Alright, so this is the formula that we use if you want to calculate the molar mass of the solute, provided we know the mass of the solute and then the mass of the solvent. Alright, now it is important to also note that for very dilute solutions, that is, the amount of solute that we added is so small that it becomes insignificant, then the mole fraction over here, which is what? N divided by N plus capital N, can be written as what? N over what? Capital N. That is what? We ignore the small m over here for very dilute solutions only. So if the question is asking you to find the molar mass for a very dilute solution, we need to replace this formula, this part of the formula, by what? Small n over capital N. That means our P minus PS on capital P becomes n over what? Small n, capital N, which is what? P minus PS on P is equal to our small n over here is what? W over what? M over what? Capital W over what? Capital M. And if we resolve this, we get that our P minus PS on P becomes what? Small w multiplied by capital M on what? Small m multiplied by what? Capital W. So this is the formula that we use for what? Very dilute solutions. All right, so let's have a look at two examples on how to use these derivations, that is what? That of the normal one without very dilute solutions, and then the one that we use the very dilute solution formula to find. So the first one we want to look at is what? The vapor pressure of ether with a molar mass of 74 is 442 millimercury at 293 Kelvin. If 3 grams of a compound B are dissolved in 50 grams of ether at this temperature, the vapor pressure falls to what? 426 millimercury. We have to calculate the molar mass of B. assume that the solution is very dilute. This one, they are being specific. They told us that we are to assume that the solution B is very dilute. So let's look at the solution for that. So we have solution. We know that for very dilute solutions, we have P minus PS on P is equal to what? N over what? Just capital N. Okay, because the solution has been, we've been told the solution is what? A very dilute solution. Now all we need to do is to substitute what we know for the mole of what? The solvent, sorry, the solute, and that of the solvent. So we have P minus PS over P, and we know the mole of what? The solute is what? Small w over what? Small m divided by capital W over what? Capital M, which means our P minus PS over P is equal to, if we resolve everything over here, we get what? Small w multiplied by capital M over what? Small m multiplied by what? Capital W. Alright, now let's look at our question. The question is telling us the vapor pressure of ether is this. Okay, so meaning ether is the solvent, so the N, okay, the vapor pressure of this, the capital N has the molar mass, okay, which is what? Capital W over what? Capital M. Alright, so we have the vapor pressure of this, that is just P, is what? 442 millimercury. Then the question is saying if 3 grams of compound B is dissolved in 50 grams of ether, so it means the mass of ether, which is the W, is what? 50 grams. At this temperature, the vapor pressure falls to this, so it means the vapor pressure PS of the solution is what? 426 millimercury. So we have the compound B, which is the solute, N, which is what? Small w over what? Small m, has a small w, which is the mass, to be what? 3 grams, and then the molar mass, small m, is what? We don't know. But now we have the capital M, okay, given to us, that is the molar mass of the pure ether, to be what? 74. So we have capital M is what? 74 gram per mole. Okay, so from here we can easily substitute all we have over here into the formula, and we get our answer. So if we do that, what do we get? We have our P, which is what? 442 minus what? 426 divided by 442 to be equal to small w is 3 over here multiplied by what? Capital M, which is what? 74, then divided by what? We have small m, which is what we have to find, so we don't know. Then we have capital W to be what? 50. Alright, so if we do this, we are having 442 minus what? 426 will give us 16 over what? 442 to be equal to 3 multiplied by 74 will give us what? 222 over what? 50m. So if we cross multiply, we get 16 multiplied by 50m to be equal to 222 multiplied by 442. Right, so if we do that, we get this side gives us what? 800m to be equal to, over here we have 98,124. So we divide both sides by 800. So we have our m to be equal to what? 122.655 gram per mole. So it means the molar mass of B, okay, the molar mass of B, okay, is what? 123, approximately 123 gram per mole. Alright, let's have a look at another example. Example number 2. We have 18.2 gram of urea is dissolved in what? 100 gram of water at 50 degrees Celsius. The lowering of vapor pressure produced is what? 5 millimercury. We have to calculate the molar mass, okay, of urea, given that the vapor pressure of water at 50 degrees Celsius is 92 millimercury. 3 mm. All right, so let's write down our solution. Because we've not been told that this is a very dilute solution, it means we are going with this as our formula, which is what? N over what? This plus capital N. Okay, so we have 18.2 gram of urea. Okay, so it means our small n is for urea. We have 1000 grams, so it means small w is what? 100 gram. Sorry, 100 gram. The small m, which is the molar mass, is what we are being asked to find. And the lowering of vapor pressure produced, it means delta P is what? 5 millimercury. We have to calculate the molar mass, which is this, of urea, given that the vapor pressure of water, so it means our P is equal to 92 millimercury. All right, so the small w over here is supposed to be 18.2. that is what the mass of the urea, and then the mass of water, which is capital W, is supposed to be 100 gram. Sorry about that. All right, so we know the molar mass of water is 18 gram per mole. So from here we can easily do the substitution and find our answer, which is what? Small n. All right, so let's have a look at what we have. We know P minus PS is what? The delta P. So we have 5 on our P, which is 92, to be equal to the top over here. We have this becomes small w, which is what? 18.2 divided by m, which we don't know, all on what? 18.2 divided by what? M, plus capital W, which is 100 on what? 18. All right, so from here, if we solve this or we simplify this, we get 0.0543. so we have 0.0543 to be equal to 18.2 on m all over 18.2 on m plus 100 on 18 is what? 5.556. all right, so if we cross multiply, we do cross multiplication, we are going to get 18.2 on m to be equal to this multiplied by this, so we have 0.0543 into bracket 18.2 on m plus what's 5.556. all right, so we have 18.2 on m to be equal to, if you multiply this by this, we get what? 0.98826 on m plus this multiplied by this, we get what? 0.3017. so we send this to the other side of the equal to sign, so we have 18.2 on m divided by minus 0.98826 on m to be equal to 0.3017. so because they have the same denominator, we just subtract the numerators, and so if we do that, we get 17.21174 on m to be equal to 0.3017. so from here our value of m is what? 17.21174 divided by 0.3017, and hence our m is, if we punch this into the calculator, we are going to get 57.049. so it means the molar mass of urea is what? Approximately 57 gram per mole. all right, now we also want to look at something we call the Ostwald-walker method. Okay, so we have the Ostwald-walker method. Okay, and this is another way of what? Calculating for the molar mass of a solute, and this one is much more easier. Okay, so from the Ostwald-walker method, it is telling us what? The relative lowering of vapor pressure is equal to what? W2 over what? W1 plus what? W2, where our W1 is what? The loss of mass of solution. This is loss of mass of solution, and our W2 is what? The loss of mass of solvent. Okay, so normally we use the Ostwald-walker method to find what? The relative lowering vapor pressure, and then after we find that, we can now equate this. Okay, so we can now equate this to what we know as this to now find the molar mass of the solute. Okay, so assuming in an experiment the loss of mass of the solution, which is W1, and then the loss of mass of the solvent are given, and you are not given the mole fraction or the mole of the solute or the solvent, how do you go ahead to find the vapor pressure or the relative vapor pressure before you use that to find the molar mass? So we use the Ostwald-walker method to find the relative lowering of the vapor pressure before we use that to find the molar mass of the solute. So let's have a look at an example of this method. So we have the current of dry air was passed through, a current of dry air was passed through a solution of 2.64 gram of benzoic acid and 30 gram of ether, and then through pure ether. The loss in weight of solution was 0.645 grams and ether was what? 0.0345 gram. What is the molar mass of benzoic acid? Okay, so in this particular example, let's write down solution first. You can see that they are saying a current of dry air was passed through a solution of, we are given the mass of benzoic acid, and we have what? The mass of ether. Okay, now they are giving us loss in weight of solution and that of what? The solvent. Okay, so we need to use the loss in weight of solution and then the loss in weight of the ether, which is what? The solvent, to find the lowering vapor pressure, okay, before we can be able to use it to calculate for the molar mass of the benzoic acid. Right, so let's go ahead. So we know P minus PS over P, according to the what? Ostwald-walker method, is equal to what? W2 over W1 plus what? W2. Now, which means this over this on P is equal to, now the W2, which is the loss of mass of solvent. Okay, we have the loss in weight of the solution. So this is for the solution, so it means this is for the solvent. So we have 0.0345 on 0.0345, which is for the W2 over here, plus the W1 is now what? This, so 0.645. So it means the relative lowering of vapor pressure from the Ostwald-walker method, okay, is equal to, if we punch everything here into the calculator, we are going to get 0.051. So now that we have this, we can easily find the molar mass of the solute. Okay, so we know that P minus PS on P is equal to what? Small w on what? Small m all over what? Small w on